Hello everyone, hope you're all doing well. In today's lesson we are going to learn what a decimal is and how to read a decimal scale. We will have been successful today if we can read, interpret and write a decimal number, and if we can read and interpret a decimal number from a scale. So let's start with what a decimal is. A decimal is a way of writing a number that is not a whole number. Decimal numbers are in between numbers. For example, 10.4 is in between the two whole numbers 10 and 11. So just to remind you a little bit about place value, we have our decimal point. On the left hand side of our decimal point is our whole numbers. We've got units, tens, hundreds, thousands, etc. On the right hand side of the decimal point is our decimal numbers, our tenths, hundredths, thousands, tens of thousands and so on. So let's look at an example here. In these questions, one whole is represented by this 1 bar split into 10. Okay, so if one whole is split into 10, remember a fraction, that just means 1 divided by 10. Each small bit is 0.1, okay? So each one of these small sections is 0.1. So if I have 1, 2, 3, 4, 5, 6, 7 of those coloured in, that means the decimal represented here is 0.7, okay? In part B, we have 1 whole bar, so that is 1 unit. And we have 3 tenths here, so 1.3 is what's represented here. Now we have circles. If I just count how many segments the circle is split into, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It means that again, each small segment represents 1/10, okay? So here we have 1, 2, 3 whole and 1, 2, 3 tenths. So 3.3 is what's represented here. Okay, so let's break this down even further. Now, if I have one whole here, it is split into 10, so if I take one of those out, that is 1/10. Now let's see what happens if I split the 1/10 into 10 parts like so. If I pull one of these small parts out, that is 100, because if I put that back into the one whole, that splits the one whole into 100 pieces, okay? If we remember in our place value, we have units, we have tenths, then we have 100ths. So each small part here is 0.01 since 1 is being split into 100 pieces, okay? So I've kept the place value at the top right in case you need it to help you. So here we have 1, 2, 3, 4, 5 tenths. So we don't have any whole segments. We've got 5 tenths and we've got 1, 2, 3 hundredths. So 0.53. We have 1, 2, 3 wholes, 1, 2, 3 tenths, and 1, 2, 3, 4 hundredths. So 3.34 is what's being represented here. Now we're going to move on to reading decimal scales. So we're going to look at one decimal place first. Before deciding what number an arrow is pointing at, we must look at the two whole numbers on either side, okay? So in this diagram here, we have the red arrow pointing at a number somewhere between 6 and 7. So it means that that must be 6 point something. It is bigger than 6, but it's less than 7. Each whole number is split into 10 segments, and we do that by counting the gaps between the lines, okay? So if you count the small gaps in between each line, you'll see that there's 10 of them. And we know that this middle one cuts it in the middle, which means that is 6.5. Okay, so again, one whole split into 10 means each segment is 1/10, 0.1. So this number must be 6.8 since it is 8 along, okay? You can go from the 6.5 in the middle since that is clearly marked. 6.6, 6.7 and 6.8 is where the red arrow is pointing at. So let's try the same with these ones. So right away I can see the arrow is lying between 5 and 6, so it must be 5 point something. Each whole number is split into 10 pieces, so each one piece represents a tenth. So if I know that this is 5.5, 1 less than 5.5 is 5.4, so my answer is 5.4. Here we have something that is less than 3, so the whole number before 3 is 2, so it's going to be 2 point something. It is 1/10 less than 3, so that is 2.9. And in our last example, again, even though it's a dial this time, each whole number is still split into 10. So I know that this here is going to lie between 3 and 4. It's going to be 3 point something. I know that that there is 3.5 halfway, so that one must be 3.6. Okay, now this time if we notice that each whole number is no longer being split into 10, it has been split into 1, 2, 3, 4, 5, okay? So rather than each segment representing 0.1 this time, it's got to represent 0.2 so that we make it up to a whole number, okay? And if you can't spot that, the way we figure that out is we say one whole number is being split into 5, which means 1 divided by 5, and if you put that in a calculator, that gives you 0.2. So each segment represents 0.2 this time. So we have 6.2, 6.4, 6.6 and 6.8, okay? So the arrow must be pointing at 7.4, okay? In this next example here, we have that each whole number is split into 1, 2, 3, 4 segments this time. So each one must represent 0.25. So we have 28.25. And again, if we can't figure that out by looking at it, we do 1 divided by 4 in a calculator to give us 0.25. Okay. So we know that this is going to be 29.25, 29.5, and 29.75, okay. In our last example here, they're trying to trick you because it looks as if each whole number has been split into 10, but you'll notice the two numbers on either side of the arrow are 5 and 7, which would make the halfway point 6. So actually each whole number is being split into 5. So we've got 6.2, 6.4, 6.6. So our answer for that one is 6.6. Now we're going to look at two decimal places. Before deciding what number an arrow is pointing at, we must look at the two numbers on either side. The only difference is now they are not going to be whole numbers, they are going to be numbers that have one decimal place. The red arrow is pointing between 6.5 and 6.6, so it is 6.5 something. Bigger than 6.5 but not quite 6.6. Okay, so each tenth is split into 10 segments. Each segment represents 0.01, okay? So we can see the halfway mark here, halfway along is 6.55. So we know that 2 after that is going to be 6.57. Okay, so last examples. So what number is arrow pointing to? It must be something between 2.6 and 2.7, so it must be 2.6 something. It's split into 10, so we've got 2.61, 2.62. In part B here, we have a number that is less than 3.8, so the number before 3.8 would be 3.7, and we would have 3.75 here. So we've got 3.76, 3.77, 3.78. And on the last one here, it lies between 0.2 and 0.3, so it's 0.2 something. We've got 0.25 here, so 0.26, 0.27. To make it a little bit harder, what number is arrow pointing to? It must lie between 0.7 and 0.8, so 0.7 something. This time we're being split into 5 if you count it, not 10. So it's not going to go up in 0.01 each time, it's going to go up in 0.02. Okay, so we've got 0.72, we've got 0.74, 0.76, 0.78. And the next one here, again, it is split into 1, 2, 3, 4, 5. So we're going to have 6.02, 6.04, and so on. If you'll notice this time, it lies directly between 6.02 and 6.04, so the number must be 6.03. And in our last one here, they're trying to trick us again. 4.7 must be here. It is split into 1, 2, 3, 4, 5. So we have 4.62, 4.64, 4.66. Okay guys, that is everything for today. This probably is revision, but it's not a bad thing to look over it again. So I'll be setting exercises on Teams. Please make sure you ask me for help if you need it. Thank you.